Greetings to everyone. My name is Kushi Gulwani. I am a student of Vocational Diploma in IT from Dalbagh Educational Institute. This is my presentation for the subject Software Architecture and Deployment, and my title is DevOps Breaking the Wall Between the Developers and the IT. Let us see what is DevOps. It is a combination and a cultural and technical movement that blends software development and IT operations. It aims to increase an organization's ability to deliver application faster and more reliable. It is done by automating processes and encouraging collaboration. It helps team build test and release software faster and more reliably. Why DevOps matters? Now DevOps give various benefits like it speed up the work, it improves collaboration between teams, it reduces failure rates and improves recovery times. It ensures continuous feedbacks from end users and system. And some of the modern businesses need these faster innovation, frequent updates, and high reliability. Now these are some of the key principles of DevOps. First is collaboration and communication. It break the silos, means the collaboration between different developers, testers, operators. It is done by automations like building tests and deployments. Continuous integration and continuous delivery, that is CI/CD. It integrates changes frequently and deliver them reliably. IAC infrastructure as code. It uses code to manage infrastructure, for example, Terraform and Ansible. Monitoring and feedback. It continuously objectify the system performance and user behavior. Now the traditional dive between developers and IT operators. So historically, before the developers used to write the code and they handed off to the IT operators or tester for deploying and testing and maintaining it, which create a wall of confusion. Now in this diagram, we can see there is a developer who wants to change something, and then there is an operator, IT operator, who wants stability. He doesn't want to change anything in the code. He wants stability in that, which creates a wall of confusion. It creates problem like blaming each other and slow releases, increased downtime, and user dissatisfaction. So DevOps avoid these delays, miscommunication, and such scenarios. Now, these are some of the tool chain of DevOps. In this diagram, that is by Microsoft Azure, we can see various tool chain that have Azure Air Artifacts, CredScan, Retros, Power BI, and collaboration with chatbot and Microsoft Teams. Rather than Microsoft Azure, we have many more toolchain. For version control, we have Git, GitHub, GitLab. For CI/CD pipelines, we have Jenkins, Circle CI, GitHub Action. For containerization, we have Docker. For orchestration, we have Kubernetes for managing container clusters. For config management, we have Puppet, Chef for provisioning the infrastructure. For monitoring and login, we have Grafana, ELK Stack, and Datadog. For chat operations or chat ops, we have Slack, Microsoft Teams with chatbots for alerts and various commands. Now, this is a diagram that shows the workflow of DevOps. First is planning, second is coding, third is building, fourth is testing, fifth is packaging, sixth is releasing, seventh is operating, and then the last and eighth is monitoring. So let us see each step one by one. Planning typically means a product manager and an engineering lead will work together to plan roadmaps, in which the teams will leverage project management tools such as Kanban boards to build out development schedules. The second stage is coding. After the planning is complete, the coding will begin by the developers, such as code review, code merges, and code management in a shared repository. After coding, the third stage is building. As the code is developed and reviewed, engineers will engage in merging or continuously integrating the various code written by various developers and the various modules created. This is typically done with continuous integration to test code changes and version control tools to track new code. The fourth stage is testing. During the build process, continuous testing helps ensures new code additions that don't introduce bugs, performance dips, or security flaw to the source code. So the fifth stage is packaging. Here, packaging doesn't mean that packing a product. It means before launching a new iteration of an application, a team will package its code in a structure that can be deployed. This can sometimes include sharing reusable components for sharing via package ecosystems such as NPM or Nugget. Sixth is releasing the project or application. The team will release a new iterative version of an application to end users. This typically includes release, automation tooling, or scripts, or to change management tool which can be used in the event a change that does not work in deployment and needs to be rolled back. Seventh is operating. Throughout all the stages of SDLC, SDLC here means Software Development Lifecycle, the DevOps practitioners ensure the core infrastructure the application needs to run on works. This includes setting up testing environments, staging of pre-deployment environments, and deployment environments. The eighth and last stage is monitoring. The DevOps practitioners implement a mixture of tooling and automation to engage in continuous monitoring across the software development lifecycle. This includes service performance like monitoring, security monitoring, user experience monitoring, and incident management. Now, these are some of the benefits of DevOps. DevOps bring wide ranging benefits across teams and the business as a whole. It is faster as compared to the market. It is frequent and reliable. That means quicker delivery to the customers. It provides better product quality. It is done by automated testing and continuous feedbacks to catch bugs earlier. It improves team morale. It shares ownership and reduces stress and promotes more of the teamwork. It provides scalability like containerization and ISE helps infrastructure grow according to the user needs or according to the developer needs. Fifth is business agility. The rapid iteration allows quicker response to the market changes. Sixth is lower failure rates. The small and incremental changes reduces the change of major issues. Seventh is faster recovery times. It rollbacks and quickly fixes are simpler with automated pipelines. Eighth is cost efficiency. The automation reduces manual work and infrastructure weights, so it is cost efficient. Now, these are some of the challenges and how we can overcome them. Even though DevOps brings major advantages, the journey isn't without any challenges. The first is cultural resistance. The team used to work in silos may resist change. The solution to it can be that we should encourage open communication, offer continuous training, and celebrate every early DevOps wins to build the trust. Second is tool overload. The vast number of DevOps tools can overwhelm teams. It can be solved by starting small, focus on core tools that integrate well and scale up gradually. Next is security concern. Frequent releases raise questions about application and infrastructure security. It can be solved by integrating DevSecOps, which means embedded security checks early in the pipeline and automate vulnerability scanning. The next is lack of skills or expertise. Teams may not have the knowledge to implement DevOps practices. So we can solve it by investing in workshops for skill building and other certification and mentorship or trainings. Thank you so much.